So again, Darrell really needs no introduction. He's director of Swanson Aviation, board member of British Aviation Group, ADS Group, so many things, 25 years of aviation experience, and here we go.
Hi, I'm Darrell. Thank you very much. Great slot to have. I'm actually quite chuffed that there are so many people left in the room today. It's been a long 2 days, but I think it's been a very valuable exercise. And I'm really pleased to see there's a lot more movement in the industry in terms of electric aviation. So I'm Darrell. I started my own company about 6 months ago, board member, British Aviation Group, largest trade body in the UK. Basically, that just means I know a lot of people. So if you have any questions and I can't answer, I know somebody who can. Helping out the ADS UAM infrastructure side, advising them on what we need to do to unlock electric aviation. And you can find me on Twitter and LinkedIn. So electric aviation, the basics, you guys really know all this stuff, so this is going to be quick. One, we've got all these guys in 150 companies producing all these various different eVTOL. Obviously, that market will thin down over time, but it's a very important part of it. And I first started looking at eVTOL soon after the Uber Elevate paper was published. But prior to that, my MBA paper was based on buying HMS Ark Royal, a British aircraft carrier, floating it south of London City Airport and turning it into a heliport. And that's actually where I discovered how difficult it is to get vertical operations in a city. As it turns out, every borough in London has a policy against heliports. Every borough in London doesn't like heliports. They're just far too noisy. In fact, the 1984 heliport study in London identified a 10 decibel bias against helicopters because there was no social utility associated with them. So following on from that, then we started coming up with the fixed-wing electric aircraft. So to me, it was a natural fit. And of course, you start talking about set-top operations. And we've had set-top operations for a little while. And the question is, why didn't they really get there? And I think it's actually the combination of electric fixed-wing aircraft and eVTOL, which is actually going to lead to a world of distributed aviation. So I've been giving this discussion for a little while now, and I apologize to anybody who's actually seen it, but I usually get asked a lot of questions, so I set out the rules of the air. One, I'm an optimist, so I believe that all the technical, regulatory, and legal barriers will be overcome in time, and that's just because there's so much money chasing this right now that the regulators and the legal people really have to sit up and take notice of this. Silence is golden. So we've talked about noise being one of the most important aspects of vertical aviation. And I think that the electric side of the equation is what's going to enable us to develop this infrastructure that will support the entire eVTOL industry. Because without silent operation, we may as well just go home because you will not get the social acceptance for these vertiports. Again, V is the key. We need to get people where they go. I started my career as planning and designing airports, eventually helping people buy airports. And airports are horrible places because you have to bring them from far out, bring them in, process them through the system, delay them by a couple of hours, of course, all while you're trying to take money out of their pocket through the various different commercial operations that you have there. People don't want to go to airports. Airports are a means to an end. So if we can get people into the city center where they actually want to go, quid's in. Piloted first and then phased automation. Automation is the future, but it is really going to take us time to get there, and that's fine. That's probably a good thing. And for everything else, refer to Rule 1. Right, so while I've been doing my research, I came up with this theory that electric propulsion is going to give rise to what I'm calling distributed aviation, and I'm really glad to hear that that phrase is starting to enter the vocabulary at events like this. So electric propulsion is going to disrupt the current aviation system and lead to a future of distributed aviation. Electric low-cost sub-regional airlines will operate on thinner routes, enabled by lower capital, maintenance, and operating costs of those vehicles. Sub-regional traffic will start to distribute away from those primary systems of airports, so the internationals and the primary regional airports, to those secondary and smaller airports with about 700 meters in field length. Now, of course, Neil can take off sideways through a small runway, but we want to include everybody else. And these smaller airports have lower charges, more capacity, which may actually be closer to the origin and destinations of the passengers. So fixed-wing aircraft will take passengers on the longer haul, where they'll transition on to either local transportation services or they'll transfer on to eVTOL services where they'll get to their final destination. Now, The inverse side of that is that larger airports may actually start to lose some traffic as that traffic distributes away from them. However, they would lose some of those smaller routes and smaller aircraft and be able to replace them with larger international flights, which is probably more in their liking because it means that they have to spend less money on infrastructure. And airport acquisition is all about minimizing infrastructure investment. The best, the most successful airport transactions have actually been leveraged off the ability to mitigate investment in infrastructure. And in time, as the technology enables larger aircraft, those aircraft will just be folded into the existing aviation system. So I had this data set lying around from 2009. This is CAA statistics. In 2009, 177,000 passengers went to Inverness Airport, down to Gatwick Airport, for domestic purposes only. They weren't flying on to Alicante or somewhere else. They were purely doing it for domestic purposes. So the question is, what could Gatwick do with that equivalent in terms of number of slots on the runway? Gatwick Airport is the single busiest runway, or the busiest single runway in the world. And every additional slot that they're able to squeeze out of it through operations equates to about £1 million in additional revenue. So it's actually worth quite a lot. So I looked at the larger set of data, and these are the passenger numbers in 2009 that went down to the London airport system, specifically for domestic travel only. They were only coming down to the southeast. They weren't flying on elsewhere. So 1.6 million for Heathrow, total of 4.7 million. That's a lot of people. So what does that mean in terms of runway slots? So if we were to assume that you could get 50% of those people off on an equivalent of 110-seat aircraft, for Heathrow alone, that could be a savings of about 14,500 movements per annum. Now, we talk about runway 3, and I'm a big proponent of supporting runway 3 at Heathrow. We need the capacity in the southeast. But that kind of difference to their business would be absolutely significant. Gatwick Airport, 10,000 movements so that they could get off of that runway on an annual basis for a long-haul international flight. That's worth a lot of money, and that's what the potential of distributed aviation actually is. And I talked about this capacity crunch. So if you go to IATA or if you go to ACI, you'll see lots of information about the delays that we're going to start seeing in airports because we haven't got the capacity to deliver the passenger growth. And this is where I'm hoping that distributed aviation can play straight into that. So instead of today's secondary airport could be a major hub in 20 years, in 10 years, they could be an electric aviation sub-airport. So of course, this is really what got things going for me. My first copy of this paper you can't read anymore because I tore it up and threw it in the bin and thought, rubbish. Picked it back up, taped it back together, reread it, and said, yeah, okay, there's something here. And I think that was probably a bit of bias because if I couldn't do it with an aircraft carrier in London, why should they be able to do it? But anyway, I got over myself. So we all know why this is happening. It's about growth and about urbanization and global cities. But more importantly, it's about the mega regions and corridors that are coming out of it. And it's these mega regions and corridors which are actually giving rise to the need for this kind of travel. And again, it's really coming down to the fixed-wing electric aircraft and the eVTOL coming together to really build that solution. So of course, we've all done our own example. So I live in Newbury, so this is my example to try and get into London to tell the Prime Minister, stop. Let's just think about this Brexit thing again. It's just getting ridiculous, and time will tell, I guess, later this afternoon what's going to really happen. And it's interesting here, when I was doing the calculations, the longest part of the journey was actually driving from my home to Brimpton, which is just a small little grass airfield, 17 minutes. Flying into London, flying along the existing heliport network, was 14 minutes. So here we get to it, the birth of distributed aviation. So we talk about the range game, and the company that I worked for before, they were owned by GE. So we did a lot of work on what's actually happening in that sector. They leased aircraft. And what we found was that although the manufacturers were producing these aircraft, they were being produced with more and more range and more seat capacity, yet the airlines were actually only flying them in that 200-mile range. So they're actually building stuff for a market that's not really there. So of course, you stick in the eVTOL right there. And then we have the fixed-wing electric aircraft stuff with much lower operating costs, much lower capital costs and maintenance costs. So this is why I think we're going to get into that distributed aviation effect. So where could they operate in the UK? So this is 249 pairs. This is 2017 data. 8,500 weekly flights, 48 airports. So if you had a vehicle that could do just 250 statute miles, you could capture 50% of the existing market. But that's not where the opportunity is. The opportunity is actually where these hydrocarbon-powered aircraft are not operating. Now, the interesting little number that I ran the other day was 22%. So there's 48 airports. That's about 1,128 airport combination pairs, but we're only flying to 249 of them. So only 22% of them are viable for hydrocarbon-powered aircraft. Now, they won't all be viable for various different reasons, but it just says to me that there is an opportunity for those types of operations to take place. Bell Nexus, where could it operate? About 20% of the existing airport pairs. But again, that's not necessarily where the real opportunity is. So we looked at the bottom 40 airport pairs in the UK, and that's the list there. Again, this is 2017 data. So I suspect that there's going to be a resurgence of traffic at regional airports. Potentially, they could develop their own eVTOL service to feed that regional traffic. And because eVTOL can operate perpendicular to flight paths, they're not going to affect operations and those precious runway slots. Now, in the UK, we have these PSO, public service obligation flights. And in Scotland, 53 Scottish airport pairs is 1,015 weekly frequencies, funded to the tune of about £60 million. Now, you could imagine what a government could do with that extra £60 million. And that takes place everywhere around the world. India has public service obligation flights, Canada, Norway, again, they all have these PSO obligation flights. And we could eliminate that by putting the right aircraft on those routes. In fact, Logan Air, as you may be aware, they're looking for those electric aircraft because they're a big recipient of those PSO, and they want to make their operations more effective. So that's what that network looks like. But again, that's not necessarily where the opportunity is. The opportunity is where those airlines are not flying. And of course, we just need to build a business case for it, and these vehicles will get onto that. So we looked at actually what is the cost. And so what we have here is OAG and Sabre data. The values there are in US dollars for one-way flights. And if anybody's ever done Heathrow to Manchester, $106 one way, $206 return to get a 9 a.m. Meeting in Manchester, that's a bargain, especially if it saves you a lot of time traveling into Heathrow, going through the system. You'll be up at 3, 4 o'clock in the morning to try and get that kind of a flight for a 9 a.m. meeting in Manchester. And the rest. So one day I was rather bored, and I took a long flight to 970 other potential operating locations. Now, of course, I did this virtually, but what it basically means is that most people will be within 15 minutes of a potential vertiport. Now, of course, they're not all going to be developed, but what it really says is that there is infrastructure around there, but we need to develop it. So, sub-regional airline opportunities. We didn't just look at the UK, we started looking at various different markets around the world. And every market that we looked at came up with the same characteristics, that there are these high-value routes, relatively short, that you could put eVTOL or fixed-wing electric aircraft on day one and be competing. And when we boiled it down, we found 296 potential routes in Western Europe alone. 141 in Asia, 196 in the Middle East. Southeast Asia is a bit more difficult because of lower costs perceived. And this is something that we worked on in Norway. So that's specific routes, specific average US dollar fares, and possible market share based on a rather pessimistic approach for those markets. And if anybody's not looking at Norway, you should look to Norway. We looked at some specific use cases, Hong Kong, Macau, and of course, Nice, Monaco. I would suspect that those operators would be the first ones to actually pivot into that space. But we have this infrastructure challenge, and without the infrastructure, this isn't going to happen. And so what I've done is I've put a very simple chart, the value of the system and the acceptance. So I've had people say that it should be a circular chart feeding back in on itself, but I really wanted to just go over the basics of it. So it's electric propulsion, lower capital, lower operating costs, lower noise, higher social acceptance, more vertiports, lower cost of travel, and the system builds and gets more and more value. As you get more social acceptance of vertiports and eVTOL and electric aviation, the value of the system just goes up. So for the OEMs in the room, I would say you need to concentrate as much on making these things as quiet as possible as you are making them fly, because without that social acceptance, there's just not going to be a market for it. So being an airport planner at heart, I have to take a look at the various different types. We'll have small airfields, we'll have dedicated urban regional vertiports. Of course, we have the city center vertiports, and it's actually very difficult to try and find them. There's just so much going on in terms of planning and design and trying to make it viable. I think the biggest thing that you need to think about is that the vertiport system is actually more described by the number of parking positions for eVTOL in that system. So when I'm valuing an airport, I look at the runway capacity, I look at the taxiway capacity, then I look at the apron capacity. And it's because of space, because you need those vehicles on the ground to process them for a period of time. So the number of vehicles in any one system is actually determined by that. It's a bit boring, but that's actually the fundamental economics of it. And of course, we're going to have various different support vertiports, either for FBO type operations, or they could move into the cargo market during off-peak periods. So just looking at some of the concept, capacity is key. You need the parking positions, and they need to be located in the right places to do it. Location, most important thing, because whatever vertiport infrastructure you build, it has to be complementary to the existing transportation network. As soon as you start telling a city that you're going to drive more people onto the roads, onto single journey Uber trips, they're going to object to it, because they're actually more about getting people off road and into public transport. So we can't compete. And the recharging issue is a challenge. So it really plays to the fundamental economics of vertiport operation. So being a good consultant, I partnered up with my friends at Pascal and Watson Architects here in London. We worked some different concepts for vertiports, and we came up with this. So this is on the back of St. Pancras Station. It's a vertiport that can do about 240 movements an hour, about 2 million passengers per annum. And it just demonstrates the need to try and put this infrastructure on top of existing transportation infrastructure, because everything is already there for it. And it offers opportunities to fly in along the railway tracks to try and hide the noise. And there are rooftops like that where you can actually have the space to do it, which is demonstrated by the number of parking positions that you actually need to have a commercially viable vertiport at that location. And ground infrastructure is a secret bottleneck. So Andreas Delman from Airbus said that last year at the Future Transport Conference that I do some work with. This is a concept out at Cambridge Airport, if you know Cambridge. Same idea in terms of bringing a sub-regional type vertiport. Now, I've written about this in this Future Transport magazine, a little bit of self-promotion, but you can find that on my LinkedIn page, just talking about the infrastructure challenge. And one of my early bugbears is about putting wheels on these vehicles, because to self-maneuver on the ground, you're not going to be able to do it, because you won't be able to have passenger operations at the same time. As soon as grandma is knocked over, that's it. So put some wheels on these things, please. So I went to the Uber Elevate Summit, and these are some of the concepts that were presented there. Very interesting. The one top left there, again at Fleming, 800 passengers an hour on their site of 1.9 acres. But the extreme opposite of that is 10,000 passengers an hour in the bottom right, which I think is more dystopian of a vertiport solution than an actual utopian solution. You need that thing. You need to position it over a highway. In fact, the other two are located over highways. So to me, that kind of defeats the purpose of this type of infrastructure. So to put it into context, 10,000 passengers an hour on 3 acres versus LAX of 20,000 passengers an hour on 3,500 acres. So you can imagine what kind of local transportation chaos you're creating with that solution. Which is why I started with the underground map in terms of locating potential vertiports. I'm not saying I have found the right the sites for that, But just looking at it in Google Earth, there are approach paths which you can use to get the vehicles in. It works with the existing H4 helicopter routes over London, and it's tied in with the existing transportation network. But we really do have to talk about that Super B noise. Noise is probably one of the most important things. I was actually lucky enough to sit in the noise simulator at Arup, and they've partnered with NASA. And I was actually lucky enough to listen to a volocopter, an early volocopter design simulation, and the simulation for a Joby S2 vehicle. Now, I was actually quite surprised at how loud the vehicles were, and the acoustics were completely different. It was hard to describe. You can't compare it to an existing helicopter. But we need to come up with that new language to describe it, and we need to get that information out to the public. We also need to get it out to the local planning authority so that they can understand what the actual issue is and why we have to address the noise. But to put it into context, it was an elevated vertiport. I was standing on the airfield, so there was no barriers between me and the vehicle. But the noise itself was quite loud, but as soon as the vehicle was turned on, it was up and flying. So we haven't got a vehicle that's spending 5-10 minutes heating itself up and getting ready. It's instant on, it's up to altitude, and as soon as it made it to transition, you could barely hear it for the background noise. And that was for both aircraft. And my first question to them is, do you have the simulation on the ground? And no, they didn't. And that's the kind of work that we need to do to enable the infrastructure investment. So challenges, of course, we have lots of challenges. Battery technology, but I think we'll get there. I think hybrid is probably a way a lot of people are going to go, and the first successful operators will be hybrid. Certification, yes, it is on the way. Again, I refer to Rule 1 for most of these. Airspace, again, people keep asking about that, but again, I refer to Rule 1. NATS, Altitude Angel, and there's a plethora of other companies out there on it right now. And the important thing is the drone industry is actually running at this so fast and so hard that they'll probably get there and get the solution in place first before we actually get there at volume with the vehicles that we're filling into that space. And vertiports, of course, we need them because without the landing places for these vehicles, there's no point doing any of this. And we need a new way of engaging with the stakeholders, both the local authorities and the people actually living around these new vertiports. Because without their support, we're just not going to get the infrastructure. And standardization, of course, 150 different types of vehicles. I get a bit upset when I hear these numbers that 10, 20 of them are going to have swappable battery solutions. So that means I haven't got a vertiport. It means I have a battery parking lot. Who's going to recharge them? What happens if something goes wrong? The other thing that gets my goat is passengers with reduced mobility. Not the passengers, but the actual OEMs. Because under European regulations for commercial aviation, they have to be able to allow passengers with reduced mobility, and now more so people with hidden disabilities, to be able to get on and off the aircraft. And I had one OEM, and I won't name them, say, well, just get a set of steps. Well, okay, well, that's fine, but there's 150 potential different vehicles out there. And the configurations of the vehicles are so different that I'm potentially going to have a steps parking lot along with my batteries. So where am I going to put all these eVTOL? So again, we need that standardization in the market. Anyway, I was Darrell Swanson. I was your anchor speaker. I hope you enjoyed. It's been a great conference, so thank you very much.